Welcome to solverfy.
So in this problem, we're looking at the reaction between sodium carbonate and silver nitrate. Okay, so this is going to be sodium carbonate. Carbonate is two minus, sodium is plus one, so there needs to be two sodiums to balance out this charge. Silver nitrate, silver would be plus one, nitrate is minus one. And notice I'm not balancing this reaction yet, okay? And this would form solid silver carbonate. Now the silver, again, has a plus one charge here. So you would need two of them, carbonate here. And then you would need sodium nitrate, NaNO3. All right, so we first write out the reaction. Now let's balance it. So we have two sodiums here, one sodium on this side. So let's double this up. And now we have two nitrates. All right, but there's only one here, so we double this up. And so now we've balanced this reaction. Okay, we can check two sodiums, one carbonate, two silvers, two nitrates, two nitrates. Okay, so our solution has 3.50 grams of sodium carbonate and 5.00 grams of silver nitrate. So we want to find out how many grams of sodium carbonate, silver nitrate, silver carbonate, and sodium nitrate are present after the reaction completes. Okay, so the first thing we need to do is find the molar mass of all of these compounds. So let's start with sodium carbonate. There's two sodium atoms, and each sodium has a molar mass of 22.99 plus carbon plus 3 oxygens. So 2 times 22.99 plus 12.01 plus 3 times 16 is going to be 105.99. For AgNO3, you have one silver, 107.87, plus a nitrogen, plus 3 oxygens. So 107.87 plus 14.01 plus 3 times 16 gives you 169.88. Silver carbonate, 2 times 107.87 plus 12.01 plus 3 times 16.00, 2 times 107.87 plus 12.01 plus 3 times 16 is 275.75. Finally, we have NaNO3. Sodium is 22.99. Nitrogen is 14.01. Oxygen is 16. So 22.99 plus 14.01 plus 3 times 16 is 85.00. Okay, so now that we've got that out of the way, we can start with the problem. So remember, when you're looking at reactions, you deal with moles, right? It's each molecule is reacting with each other, not each gram, right? So we first need to convert these into the number of moles. So we have 3.50 grams of sodium carbonate. And all we have to do is divide by the molar mass to get the number of moles. And this would be 33.0, I'm going to say millimoles. Okay. So that's just moles times 10 to the negative 3. I'm just doing that for simplicity here. Okay. Now we have 5 grams divided by 169.88. That's 29.4 millimoles. So this is what you're starting out with, right? This is the initial. How much is this going to change? Well, we need to find the limiting reagent here. Okay, so to find the limiting reagent, you take the number of moles and divide it by the coefficient. So we can do this. Where would be a good spot to do this? Let's do this above here. Right. So 33.0 divided by 1 is just 33.0. And we don't need to be super formal about this. This is more of a back of the envelope thing. 29.4 divided by 2 is 14.7. 14.7 is clearly lower than 33.0. So this would be the limiting reagent here. Okay. And because this is limiting, that means all of this is going to react. So what's going to happen in the middle here? Well, this 33 millimoles, it's going to lose some amount, some X. This silver nitrate is going to lose some amount, 2X moles, and it's going to make these start out at 0. And it's going to make X moles of Ag2CO3 and 2X moles of NaNO3. Okay. So how do we figure out how many moles are reacting? Well, 29.4 minus 2x equals 0. So therefore, x equals 29.4 over 2, x equals 14.7. So 33 minus 14.7, that means 18.3 millimoles react. We know the silver nitrate is limiting, so we already know it's 0. So that means 14.7 millimoles of this, 29.4 millimoles of this. Okay. And now all that's left to do is convert this into grams. We can start with the easy one. This is a 0 grams. 18.3 millimoles. So don't forget to multiply 18.3 times 10 to the negative 3 times the molar mass of sodium carbonate, 105.99. We only have 3 sig figs here, so this is 1.94 grams. 14.7 times 10 to the negative 3 times 275.75. That's 4.05 grams. And finally, 29.4 times 10 to the negative 3 times 85 grams per mole, 2.50 grams. Okay? So if we were to summarize our answers, sodium carbonate, we get 1.94 grams left after reaction. We have 0 grams of silver nitrate left. We have 4.0 grams of silver carbonate formed and 2.5 grams of sodium nitrate formed. And that's the reaction.